All right, we're going to go over the classifying rocks reading notes, and then right after that, we're also going to go over the igneous rock reading notes. So, as I go along through these notes, just make sure that you are following along. I would also encourage you to make corrections to anything that is different from what I have. That may require you to add some things. This is important when it comes to again those open note, open book quizzes that we're having. Um, so I take the questions off these notes, and I feel like more of you should be doing better on those if you have your notes done correctly. So please follow along here. All right, so now we're talking about classifying rocks. Okay, so key questions. You guys know you've been here, a couple months now that we always start out with these key questions. And again, boys and girls, all this is kind of the big idea. What do we want to take away from this reading? And in this first reading, we're talking about how do geologists classify rocks, okay? So we're going to answer that here, and it's right here. To classify rocks, or how do geologists classify rocks? They study a rock sample, they observe the rock's mineral composition, color, and texture. So they look at the rock sample, they look at what minerals make up that rock, they look at the color, and they look at the texture of the rock, and that is how they classify the rocks. So let's break this down even further. Mineral composition and color. Rocks are made of a mixture of minerals and other materials. Some rocks only contain a single mineral. Other rocks contain several minerals. Then we're going to talk about rock-forming minerals. About 20 minerals make up most of the rocks of the Earth's crust. These are known as rock-forming minerals. And anytime you see this means this is a vocabulary term. So you need to know the definition of rock-forming minerals. And the definition is right here. The 20 minerals that make up most of the rocks on the Earth's crust is known as rock-forming minerals. A rock's color provides clues to the rock's mineral composition. Okay, remember quartz is a white color. So if you see specks of white in rocks, usually that signifies either it's got calcite in it, because calcite is also white, and so is quartz. So that is a clue to what may be in a rock just by looking at the rock's color. For example, here we go, granite has generally a light-colored rock that has a high silica content. What that means is that it is usually rich in the elements silicon and oxygen. Basalt is another type of rock that is dark-colored that has a lower silica content than granite has. So it doesn't have very much silicon and oxygen. Okay? So most of you probably are doing this at home. Hopefully, you had some time in class to do it. If you are in class and you are listening to this right now, sitting in class, I want you to quietly say, not too loud, please don't scream, quietly say, rocks are cool. If you're home, you can say that as well. All right, here we go. Next page here. So, texture. Most rocks are made up of particles of minerals or other rocks, which geologists call grains. It's another vocabulary term here. Grains give the rock its texture. Texture is the look and feel of a rock's surface. To describe the texture of a rock, geologists use terms that are based on the size, shape, and pattern of the grains. Okay, so let's look at types of grains. Fine grain rocks have grains that are so small they can only be seen with a microscope. We're going to look at and feel some fine grain rocks in the labs that we have coming up. Coarse grain. Coarse grain rocks have grains that are large and easy to see. And then there are also no visible grain rocks as well. We will look at these two, fine grain and coarse grain. Grain shape. I'm going to go ahead and take this on down here. You have rounded grain results from the shape of the mineral crystals that form the rock. Jagged grain result from the rounded or jagged bits of several rock. And look in the reading. I think the best way to understand what this is telling you is to look at the picture. If it is jagged, it has several bits of rocks in it. If rounded grain results from the shape of mineral crystals that form the rock. So look at the two examples that they give you there in the book, and I think that's the best way really to understand what this is telling you here. Grain pattern. You will see this. You will see banded and non-banded. Banded rocks, rock grains lie in patterns of flat layers or can form swirls of colored bands. You will see banded and non-banded rocks. I also say it looks like it has layers. It looks like you just can clearly see the different colors, and it just looks layers, like it's just been stacked on top of each other. Non-banded, you don't see that layering. And again, I think the best thing to do, I'm a very visual learner, is to look at the examples that are in that reading. That is the best way to understand the difference between banded and non-banded in the grain pattern. Okay? All right, so we're going to go now talking about origin. This is the biggest one on how rocks are classified. They're based on where they came from, how they were formed. And geologists have classified rocks into three major groups: igneous, sedimentary, and metamorphic. Okay, so we're going to go over the igneous rock reading in just a minute. But igneous rock forms from the cooling of magma or lava. Now get this, boys and girls. When lava or magma is under the ground, it's called magma. But once it reaches the surface, it's called lava. They're the exact same thing. So it's that hot, fiery liquid that comes from volcanoes. If it's in ground, it's called magma. If it is above ground, it is called lava. Okay, so let's make sure we understand the distinction there. Okay, the magma hardens underground to form rock. The lava erupts, cools, and hardens to form the rock on the Earth's surface. Sedimentary rock forms when small particles of rock or the remains of plants and animals are pressed and cemented together. Sedimentary rocks form in layers that are buried below the surface. Metamorphic rock forms when the rock is changed by heat or pressure or by chemical reaction. Most metamorphic rock forms deep underground. So three types of rocks that we're going to look at: igneous, sedimentary, and metamorphic. These are the only three types of rocks there are, by the way. And we will look at examples of all three of these. All right. Igneous rock reading notes. So what are the two big idea key questions being answered? How did geologists classify igneous rocks? And how are igneous rocks used? I want to tell you this. That last key question, I can't tell you if there's really going to be any questions on quizzes or tests coming up where we talk about it. Okay? It's good information to know, but I want you to focus on what are the three main types of rocks and then the little subdivisions in those. So you're going to look at that in just a second with igneous rocks. So how do geologists classify igneous rocks? Igneous rocks are classified by their origin, texture, and mineral composition. So when you look at origin here, this is real big. Igneous rocks may form on or below or beneath the Earth's surface. So you have extrusive rock. Extrusive is igneous rock formed from lava that erupted onto Earth's surface. Basalt is the most common extrusive rock. Okay, so think of exit. It has exited the Earth. It has cooled very, very quickly on the Earth's surface. Therefore, the minerals, the crystals, are usually smaller because they're erupted out of the volcano, cools very quickly. Okay? Intrusive, think of inside. Intrusive is igneous rock that formed when magma hardened beneath the surface of the Earth. Granite is the most abundant type of intrusive rock. I think there was a typo on your notes there, so just correct that there. I apologize. So, these rocks usually have very large crystals, okay, because they form and cool very, very slowly beneath the surface of the earth. And you're going to see granite. You're going to look at basalt. You're going to look at some other extrusive igneous rocks as well. Okay? So those are the two main types of igneous rocks: extrusive, and intrusive. Okay? So if you're sitting in class right now, or if you're at home, I just want you to stand up out of your chair. I want you to get a nice big stretch, sit back down, and let's continue to learn about rocks. What do you say? Are you pumped? I am. All right, here we go. Texture. Rapidly cooling lava forms fine-grained igneous rocks with small crystals or no crystals at all. Just what I said in that last bit a few minutes ago. It forms, it cools very, very quickly. Therefore, the crystals are very, very small. Usually, it's extrusive igneous rock. Going down through here. Slowly cooling magma forms coarse-grained rocks, such as granite, with large crystals. Usually intrusive igneous rocks. Mineral composition. Lava that has low silica usually forms dark-colored rocks such as basalt. Basalt contains feldspar as well as certain dark-colored minerals, but it does not contain quartz. Magma that is high in silica usually forms light-colored rocks such as granite. Granite mineral composition usually determines its color, which can be light gray, red, or pink. Okay? So the color tells you basically, again, what type of minerals are present in that rock. How are igneous rocks used? People throughout history have used igneous rocks for tools and building materials. And in your reading, give some examples of that. Okay? Well, I can only imagine that you're probably happy that you're done with this. Again, please make sure that you have all this as it is written here on these pages, written into your notes, that you can use these to do well on quizzes. All right? So one clap that you're done. Have a great night or a great rest of your day if you're still in class.